Hello, welcome to today's session. We're going to create a live dashboard using the new Power BI connector with our guests here from Databricks. And we're going to start with Leo Furlong. We've also got Kyle Hale here. And Leo, I'll turn it over to you.
Hi, everybody. Thanks for joining today. I'm going to share my screen really quickly. And so actually, this is the goal for today. So right now, you're looking at a Power BI report. And we're going to take a look today at how we actually create a Power BI report connected directly to Databricks SQL through the lakehouse. And we're going to explore some of the New York City taxi data and kind of basically explore that data, kind of take a look at some graphical data and how we might kind of create that capability between using different types of storage modes between import and direct query directly against the Azure Databricks SQL lakehouse. From that standpoint, I'm going to turn it over to Kyle to kind of get us started for today.
Fantastic. Let me share my screen as well. So let's get some context for that before we hand it back over to Leo to kind of see that how it's being done. Just one second, let me turn this on to do not disturb. Let's have a nice session here. So, first today we want to really kind of in some ways build upon a partnership that's already been in existence. So, Databricks and Azure Databricks in particular has always been kind of a forerunner of bringing data and analytics to engineers and scientists to bring insights forward. And then Power BI, of course, is that excellent, has its own visualization capabilities as well as data modeling capabilities. And they've actually had a connector that's been there before, but with the release of Databricks SQL, we've really taken this a big step forward in terms of making not only the integration between these two kind of systems really nice and clean, but the experience for engineers who are familiar with SQL, and definitely for engineers who are familiar with BI and analytics tools, to come and more easily than ever create useful data assets in Databricks, provide those to users in Power BI for consumption, and then be able to kind of manage the overall data pipeline and lifecycle between these two systems together. And so we've got a nice kind of a summary kind of feel on this that hey, they're working better together. And really Databricks SQL is a big piece of this. So if we step back really quickly and say, well, where did Databricks SQL come about? There's always been Spark SQL. Kind of tell us a little more about that. And really what we've seen is that, so Databricks really is kind of centered around this lakehouse concept. And the lakehouse concept, of course, if you've been watching the previous videos in this series or otherwise, is kind of saying hey, can we take the data lake, the traditional kind of able to store files, be able to store unstructured data, and apply robust data management on top of that? And so can we actually supply database-like experiences, both from a performance, security, governance, and even things like using SQL, using the native languages that people use to talk to databases in. And so Delta as a format, it's an open source format that the Databricks team has kind of led the effort, I think, in kind of pushing out there. And from that has evolved the concept of the Delta Lake. And then what we've seen is that as we introduce Delta as this format to kind of, I would say again, emulate or in some ways improve upon table-based semantics of the traditional database, we've seen a big uptick in SQL growth, and that's the chart we've seen here on the right. So kind of since the release of Delta and the concept of SQL, more and more of our users are coming in using SQL out of the box to go interact with this data, which of course makes a ton of sense. We've made that available as a first-class citizen language in our systems, and we'll continue to do so. And so the key thing here is that okay, if all of your data is going to be in the lake, and we don't want another data warehouse, we don't want another silo, we want this to be that one-stop shop for all of our data ingestion and processing needs, then we obviously need to provide a really good SQL experience. And of course, that's going to lead to BI tools being able to consume that as part of that SQL experience. So really quickly, Databricks SQL, analytics on the lakehouse. So again, we talked about sitting on top of Azure, ton of data sitting in maybe your Azure data lake today, trying to give you that's really good economics, right? So just be able to do cheap storage is kind of the future of the cloud for data. It's a great paradigm. It's served a lot of great businesses and enterprises today. But then the key thing comes is, okay, well, how do we get kind of good performance on top of that? Because, hey, if you just put a bunch of data in your data lake and say, oh, we'll just do some querying on top of it, without some sort of, I guess we'll call it thoughtfulness, and that's what this box kind of represents all up, is a thoughtful approach to putting structure on top of this data lake so we can get fast and predictable performance for all of our queries. Obviously, simplified administration and governance on top of this data lake, and then analytics, capabilities within a lot of different tools. Databricks itself provides a lot of native tools inside of ours for interacting with this data. But we also, obviously recognize there's awesome, integration tools and points for us in BI tooling like Power BI. And so by putting that platform security administration, making sure we have lots of open formats, and putting a good amount of data management governance, we enable from this data lake, the Delta Lake, and ultimately the Lakehouse platform of being able to provide the last mile before your, whether it's your traditional ETL layers, just kind of munging things together, your data science and machine learning workloads for feature engineering and model training and development, obviously for real-time data applications, for streaming jobs, and even micro batch style jobs, being able to provide those kind of experiences. And then, of course, the last and most important one is the semantic layer, which BI tools offer in spades. Power BI has a very powerful kind of semantic layer paradigm, and we're able to kind of serve as the layers right up before that. So your storage layer, your processing layer, and ultimately your kind of your equivalent of your traditional data warehouse layer. Now you can replace that with a lakehouse layer and be able to consume that in BI. So it's really powerful. That's really where those things come together, is we provide everything right up to that kind of semantic and modeling layer. And from that, we have first-class Power BI integration. So there's a native Power BI connector. Leo will be showing this off today, how you can connect directly from Power BI to Databricks SQL endpoints and clusters. Within there, we provide enterprise-level security, both on the Databricks side with Azure AD, as kind of the main driver of user identity and access management. Databricks table ACLs, so providing permission to different assets to different users and groups with a lot of fine granularity, and even granularity for row level and column level security, which will then be respected by Power BI. So Power BI user logs in, you know who they are, you supply some row level security in Databricks SQL, and you can apply that user's security to that data set and only let them see what they're allowed to see at, again, at the table level, the row level, and even at the column level. And of course, this supports self-service and enterprise BI usage patterns directly from here with enterprise performance. And this is what I was talking about earlier, is we're trying to close the gap of having to move your data one more time to a dedicated warehouse or database to get those same SQL semantics and experiences that your users are used to. And also that performance that obviously a database is giving you. And we're really kind of proud of what we've been able to do Lakehouse. If you haven't seen our recent TPC-DS benchmark, highly recommend that you go check that out. But we've been able to get really, really good world-class analytical performance on top of Azure Data Lake Storage with our Delta Lake and Lakehouse approach, and BI tools can take advantage of that. And then we also have some flexible storage options. So we have this support for import mode. So if you're used to Power BI, these terms hopefully are familiar to you. If not, import means that you're bringing the data in memory into Power BI in the desktop tool or out in the service, both are the same, pulling that data in memory. We can leave it direct query. That's where you actually leave your data in the source system. That would be Databricks in this case. And then Power BI just becomes the visualization and kind of still the logical model layer. So when you're creating, for example, relationships between tables, calculated columns and DAX measures and things like that, those can all still be created in Power BI, but ultimately the underlying data store and where the calculations and performance are being actually run are in the Databricks environment. And then composite models, where we can actually see we can combine the two. And again, we'll kind of see some of this today, as part of our demo with Leo. And then finally, we're going to also even see hybrid tables. It's a new preview feature. We're not going to see this today. There's still, I think, a few kinks to be worked out, but very soon and very shortly. Again, if you're old school, of whole app tables, where you're able to combine data that's stored in memory, available very quick, pre-aggregated for that import performance. But then also able to get the latest and greatest data into direct query, where you may not get all that extreme performance, but the latency now is gone, right? So you get all of your fast data for your data that's already been brought in, but then all of your newest data that's just coming in the pipe, you still can make it available to your users in a single table, in a single seamless user experience. So users don't care ever which of these modes or models their data is coming in. They just want it to work. work well, work fast, and be exactly kind of what they expect when they engage with it. And so having this support for all of this flexible storage options with Power BI and Databricks SQL, you can build a lot of models that can serve a variety of use cases, very powerful. And then even now, today, we offer 2 additional kind of bonuses within the Power BI driver that we offer in our connector. One of them is Cloud Fetch. Cloud Fetch is it's literally the idea that, hey, if we're bringing down a bunch of large data sets or files, well, say rows for a data set, and we want to pull them all down, traditionally you're single threaded, you're kind of limited by the bandwidth that you can pull out of one thread or one CPU. And really we found that was insufficient when you were bringing large amounts of data down into tools like Power BI. And so Cloud Fetch was built to essentially parallelize that. There's nothing fancy about it. It works great, which is really cool. And just to get things work, sometimes it's fancy by itself. But the idea is simply when you put in a request for a large amount of data from Databricks, Databricks can actually supply those as a set of parallel files and tell the driver to download those again in parallel, maximizing ultimately the throughput of that data, being able to move that data sometimes as much as 10 to even 15 times faster than it was before. This is available out of the box in the Power BI connector. You don't have to turn it on, configure it, do anything with it. It's just available right there in it. The other piece of this is incremental refresh. So again, Power BI offers the capability for a given table, just like our whole app model that we were talking about. Even if you don't use that paradigm, you may have a table where you don't want to reload all your 5 years or 10 years worth of supply chain history every single time you add one new row. And so from this, we come up with the concept of incremental refresh, where we divide your table up into partitions according to some scheme, usually date time, but doesn't have to be. And then we are able to choose which of those partitions to refresh. And Databricks, again, can take advantage of this. And this is really where that whole app model will really start to shine, is we can actually choose which of those partitions are going to be imported, which ones will be direct query, and then ultimately which ones are you able to refresh as new data comes in. And so you can kind of way more intelligently manage ultimately the data that's being exposed in Power BI for your users. Really great integration story right there. So last piece of this, we just want to talk about like kind of the good way to go about this. So building a curated data lake. Again, the challenge with a data lake always is, well, if you just throw your stuff in a junk drawer, you've got a bunch of junk. You do need to spend a little time cleaning this up. So we give this kind of, I'll call it an opinionated approach. And so the question, the idea here is that, hey, we want to bring our data from, lots of different methodologies for bringing data in to the Delta Lake. We provide a couple of these are our native platform pieces. Autoloader, for example, to kind of put a fine point on it, is if we don't understand or know the schema of the files that we're bringing into our system, or we expect them to evolve, or they're managed by a third-party API and we just don't want to worry about it, we can use Autoloader to point that to a folder and say, as these files come in, load them. And as that schema does evolve or drift in any kind of way, Autoloader will automatically handle that and provide, kind of with that semantics for how to deal with those drifts and evolutions within the bronze tables that you're creating. We have structured streaming, obviously, to stream data into our all through our tables that we make available here. We have batch jobs as well. I guess we'll call it the traditional ETL pipelines. Copy into, again, kind of similar semantics to Autoloader, trying to make it easy to move data from your data lake, so it's not Delta-fied, if you will, into Delta tables fairly quickly. We also offer Partner Connect. It's a set of third-party services that we offer through the Databricks workspace. There's integration points that partners are able to kind of come in and kind of help you spin up quickly ways to both ingest and, from the Power BI side, actually consume. I think Leo will be showing this off on the consumption side for Power BI. And then what we say is like, okay, once we brought, and then of course, Azure Data Factory being an awesome native tool within Azure to land data in the bronze tables as well. It's got a Delta sync built into it. So you can take data from any source that Azure Data Factory can consume, transform it as much as you want inside Data Factory before that, and then land it here in the bronze table as well. And then our idea, of course, is bronze is raw. We would love to take them forward into different layers. We have a specific medallion architecture of 3 layers, from bronze to silver, where we've cleansed some of this data and filtered it. And then gold, we're providing business level aggregates. And again, when we talk about those composite models, this is a great example. Gold would be the sorts of things we import, and then silver would be the sorts of things we leave behind as direct query, so that users can kind of experience these both. And again, Leo will be showing this in a little more detail later on. But we really kind of like want to pitch this as a pattern for, again, any data lake, whether you use Delta or not, whether you use Databricks or not. You definitely want to have some concept of allowing all things and being very open in what you will accept on the front end, being a little more prescriptive about how we're cleansing and ranging that data to move forward, and then obviously being able to provide aggregated insights against big data sets that otherwise aren't going to be consumable in tools like Power BI with their kind of in-memory limits. So walking right up to those limits and providing the most useful things we can there, while still having this awesome backfill of data in your silver layers and even in your gold layers that may not still make it into Power BI for consumption by your users. Okay, I think that's it for me. I'm going to turn it back over to Leo. And Leo, were there any questions, I guess, or anything coming up before we hand it over and switch gears here?
I don't think anything that we would cover from an audience level. There is one question that it's pretty specific that you might be able to answer. If not, we'll try and follow up.
Okay, well, I'll jump over to Q&A and answer that question if possible, and otherwise I will turn it over to you, Leo.
Okay, sounds good. Thanks, Kyle. Well, cool. I think everyone can see my screen now. Before we kind of jumped in, I did want to tell everybody a little bit about my background, just so we can kind of level set like where I'm coming from. But my name's Leo Furlong. I'm actually an Azure SA at Databricks. With being an Azure SA, some of my responsibilities are actually to be a SME on Azure Databricks, and so I help the Databricks SAs at Databricks, and also the Microsoft CSAs within the Microsoft communities that I serve, to effectively kind of understand Azure Databricks and some of the ins and outs and some of the the more refined features that have to be kind of learned on the actual product. From that standpoint as well, I also function to help people. I also help effectively just kind of like how Azure Databricks integrates with the other Azure Data Services, and what are some of those integration touch points and kind of the ways we actually kind of create those patterns. From a career standpoint, I came to Databricks a little bit early last year, and I was actually I would actually call myself kind of like a traditional, basically Microsoft BI consultant. So I did a lot of work with Power BI, connecting to SQL Server. I did a lot of development of the data warehouses and developing like ETL routines with like SSIS as an example. And then probably within the last like 2 to 3 years, I started exploring Azure Databricks and getting a little bit more understanding of basically this kind of Spark environment, and then learning that it's actually really not that scary, and that it actually supports SQL really well through Spark SQL and even ANSI standard SQL now through Databricks SQL, and kind of basically came to learn and understand this kind of lakehouse paradigm and pattern that kind of Kyle gave us a brief overview of, and kind of fell in love with it. And so that's why I'm here at Databricks now. I'm decent at Power BI, as we'll kind of see. I'm not great at like creating fantastic visualizations. I did come from like an analysis services type of world, and also kind of like a Power BI world where I developed a lot of kind of Power BI enterprise kind of semantic models through Azure Analysis Services and through Power BI. And so I'm pretty familiar and kind of comfortable within that space. And then my data visualization skills they're okay. So today, we're going to kind of dive into the New York City taxi data. If you haven't actually experienced that before, and if you actually never experienced Azure Databricks SQL before, we're going to kind of start from scratch, from kind of like basically from beginning to end, and kind of see what this looks like. For starters, whenever I am kind of tasked with actually kind of creating a dashboard in Power BI, the first thing that I typically like to do is actually to kind of go and take a look at the data and do some data profiling. And so, from that standpoint, if you were tasked with that, like, what would you actually do? The first thing that I would do is actually, figure out how do I get access to Databricks SQL. And so, typically what's going to happen is, as a user, you're going to get provisioned into a Databricks workspace environment through like an Azure Active Directory kind of schema integration process, and you'll be basically able to go to the Databricks workspace URL. Within that, there's going to be this concept of different personas that actually can be kind of viewed from like a landscape standpoint directly within the Databricks workspace. And so I'm going to kind of browse down and go to SQL. From here, you'll notice I have a couple of different kind of options on the flyout menu on the left-hand side. What I'm going to do now is actually just go and see what data that I actually have access to. So I'm going to click on the Data Explorer button right here. And then with the Data Explorer button, you can see that there's basically catalogs and different databases that I can see on the left-hand side. I'm going to go ahead and click on the database icon. And today we're going to be kind of looking into a taxi database. And so within the taxi database, you can see this is kind of some like some raw level tables and also some more refined tables that have actually been kind of created through a data engineering routine. I'm not planning on going through the data engineering routine today. I think that's kind of like a completely different demo. And I actually think we've actually kind of covered some of those topics on some previous sessions. So today we're just going to kind of look at the data and kind of profile it a little bit, and then start playing with it and kind of interacting with the data within Power BI. But notice here, like I'm connecting to a database. If I'm more comfortable in like a SQL Server environment, this is the IDE that I would use to go and basically explore the data and do some data profiling. Very similar to SQL Server Management Studio as an example. I can click on that table. I can see the schema of that table. I can see the size of that data and how many files it includes within Azure Data Lake Storage. I can look at the sample data and kind of browse through that. I can look at some of the details, like what's the actual storage location of that data? Is it external or is it managed? And I can even look at the permissions. And if I'm an administrator, I can even set the permissions directly from this UI screen by kind of adding people and then selecting their permissions directly within this UI and hitting OK. So the Data Explorer within Databricks SQL has a lot of capability. Within the concept of the Delta Lake storage format, like Kyle was kind of explaining to us, Delta Lake storage format actually supports ACID transactions and version history, and even the ability to kind of roll back and look at different versions of history through the actual code, through SQL code. And so here you can see in this daily trips table, I've got two different versions within iData. You can see that my first operation was actually to do a create table select statement to kind of populate the table. And then from there, I actually ran an optimize command on top of the storage to kind of make sure that it was kind of ready for giving kind of good performance from a query standpoint. So some of the tables that we're going to work through today that are kind of like some of our more of our gold or kind of refined tables. We're going to take a look at the daily trips. This is going to be really more of like a summary table. We'll kind of like look at the data a little bit more on another UI screen in just a second. We're also going to be using our raw trips table. And this is going to be more of that, like we're going to dive into the details of the data, and we're going to kind of take a look at, kind of like more of the individual transaction, kind of like what's going on actually on in our data set. You can see here, this is this data set's, is not small, right? So it's 9.1 gigabytes of data, 82 files. You can see this is kind of like a pretty typical kind of transaction record with keys joining to other kind of dimension tables. I've got some metrics over here on the right and whatnot. And then we can also go to some of our dimension tables like our taxi zones and just kind of see the schema and whatnot as well. So from here in Object Explorer, the next thing I might want to do is actually effectively kind of create queries or actually kind of run some queries in this IDE directly against Databricks SQL. So from here, I can click on the queries button. I can see which queries I already have access to, maybe some queries I already created. And two queries I'm going to run through right now. Actually, I've already got loaded on another tab just for simplicity, but I can create named queries, I can tag them, I can add metadata to kind of, and I can also share these with others kind of directly within this interface. On the SQL editor portion of the UI, right now I'm actually kind of creating some queries. You can see there's a tabbed-based experience where I can create multiple tabbed queries across the top. Right now you can see I'm connecting to my taxi database and all the tables that I have access to, and just kind of quickly kind of going to go through and just kind of query these tables and just kind of see what the experience looks like inside of Databricks SQL through this IDE. We can see that my daily trips table has roughly 18,000 records. My largest table, my raw trips, is no slouch, coming in at a 396 million records for this data set. And then again, kind of looking into the details of that, if we look at that by year, we can see we just have 2016, 2017, 2018, and 2019 loaded. And actually, this is only half of 2016 because the New York City taxi data set in middle 2016 actually trying to change their formats. And so I just wanted to create a simple ETL routine process in another demo, but to kind of refine that into a single table. The next thing I'm going to kind of review is just some of the dimension tables. I did want to point out I actually used an old colleague of mine's blog post to actually create a date dimension table. If you're a Power BI developer, you're probably pretty familiar that Power BI has this own kind of concept of creating its own kind of date dimension within the product. But if you want more control over your date dimensions, it's kind of a best practice to kind of disable those kind of auto date dimension kind of creations and then actually kind of roll your own date dimension for your organization that has kind of a custom calendar hierarchy, maybe custom fiscal hierarchies and things like that. And so this is my date table that I created. And then my former colleague Chris Kester was nice enough to actually put this into a Git repo that's public, and it just kind of shows how you would actually create a Spark-based kind of dimension table within Databricks. And so from this standpoint, I just used a statement called show create table taxi.date. So date is a view. You can see on the left-hand side little glasses on the table that make it indicate that it's actually a view. And then you can see the syntax for the view that I can actually copy and paste into the UI screen just for easier consumption and kind of looking at the data. And then from a technique standpoint, this is a pretty slick technique. So I'm going to create a CTE called calendar date, and it's equal to basically a sequence of dates, kind of start to finish with an interval of 1, and then I can explode that kind of sequence into rows. And then from there, from a technique standpoint, I can create different kind of attributes for my date dimension table. So I can create an int-based kind of date key. I can create a regular calendar date. I can create a year column, a calendar month column, a month of year column, all with just basically Spark SQL functions that are in format functions that are readily available to me through the Spark SQL language. So that's a pretty nifty technique that I used from my former colleague. And then from there, I could, if I wanted to, just access that view directly into Power BI. But in this particular instance, I'm just going to persist this to a table to get some better performance. So I'm just creating a CTES statement. So I'm creating my table taxi dim date using delta, specifying location, and then as select start from my date view. From there, I got a couple other dimension tables. So I've got a taxi zones data table. Within this, basically the pickup zone and the drop-off zone for each of those kind of individual kind of raw transaction trips is kind of recorded within the record. And within that, it tells me the borough, the zone, the service zone. It actually gives me the latitude and longitude of kind of where that pickup zone is. So I can kind of see that on a map, which is really nice. There's not really a vendors table within the taxi data set. There is a vendor ID and the transactions, but I just kind of created a simple dimension table, even though there's not a lot to go onto it. And then finally, there's just a payment type table that just indicates how the people, those trip people on those trips actually kind of paid for their trip. So from that standpoint, again, we've kind of connected to the data set. We've done a quick little profiling. I want to start off by actually showing you the Power BI report that I've already developed. And then there from the rest of the session, we're just going to kind of basically recreate that Power BI report and kind of see what that looks like, kind of going through creating a Power BI report using the Databricks SQL connector and connecting to Databricks SQL. So the report I already created, I've got that pulled up right now. I've got my kind of trip count by basically my drop-off boroughs. So again, within that trips data, we have the concept of kind of like pickup locations and drop-off locations. This is kind of analyzing those drop-offs by borough. As you can see, basically Manhattan is the primary target of where people are actually going for calendar year 2019 in the month of March. Kind of looking at my data, again, developing a Power BI report against Databricks SQL is going to be a very similar experience when connecting to other types of data sources like SQL Server, Azure SQL Database, or something like that. In this particular case, this whole page that I'm building off of right now is actually built off my summary table. So kind of going back to my data set, I split, just to kind of show how you might handle this when you have like a large record set for interacting with Databricks SQL. I created a kind of a summary table that it's only 18,000 records, right? And so I can create summary visualizations using that summary table and potentially import those records as well to give the user a very fast kind of interactive experience. And then when I want to kind of get into the details, I've got my raw trips table. I'm gonna, so I don't have to store a bunch of transactions in memory within my Power BI file. I'm going to leave that as direct query. And then when users want to get into the details, I'm going to issue a little bit more specific queries going to my raw table to kind of look at data. And so this whole kind of front dashboard is actually all developed on my trip summary table. So like here, I've got my card. You can see that for the month of March in 2019, there were 8 million trips. The prior month had 8 million trips. The cards do round up, so you can see but they are pretty similar for each of the different boroughs. And then here I can see for my month of year, I can see how that's kind of changed over time. I can look at my current month versus my trip count prior month for each month across 2019. I can see from a days of the week standpoint that my trip count, effectively kind of increases, throughout the week. So, Thursday, Friday, and Saturday are the most popular, times of the week in order to kind of take trips, taxi trips into the city, or just kind of around the city. And of course, using the capabilities of Power BI, I can use the kind of the slicing or kind of the interactivity capability. So I can click on Saturday and I can see how that data is represented in the other visuals through the highlighting functionality within Power BI. And then finally, here in my map, I'm actually showing the map visual right now through the trip counts by drop-off row through my summary table. So those are going to come up really quick. But then I have a tooltip that allows me to basically kind of query the more detailed table, show the kind of the map points at a very kind of distinct location within the different boroughs, and also show some of the kind of the key metrics for those boroughs as well. Mostly kind of looking at some of the averages so we can get an understanding of kind of what's the average kind of amount of money and distance and fare that we would actually pay kind of getting from this drop-off location. From there, in this report, I've also kind of created some drill through capability, just going to show off some of that functionality from the Power BI. So I'm going to right click on one of the report and we're going to go to zone details. And this actually is hitting my detail table. So this is hitting the 4 million record, the 400 million record, kind of fact table that we took a look at a second ago. And I've got this report kind of basically pulled up by pickup locations and drop-off locations. So I wanted to be able to kind of look at, where I'm getting picked up and where I'm getting dropped off to see like what's the most kind of trip pattern within the data. So you can see here, I'm going to click on the JFK airport and effectively kind of see where most people are kind of getting dropped off within the Queens borough that I selected previously, and and within the table below we can see those individual locations that have been kind of filtered down between the JFK airport pickups and where I'm actually dropping off, actually within Brooklyn. I can see the trip count, the average distance, passenger count and whatnot, and I can kind of really drill into the details and kind of slice into the details and kind of mix and match those storage modes to give the user the best experience possible, but still allow them to kind of drill into the details of this data. So Kyle, I don't know if we have any questions so far, but this is kind of the dashboard that I built for the demo, and we're going to kind of drill into how we would actually kind of create this today using the Power BI connector for Databricks SQL.
No questions so far. Please proceed.
Okay, sounds good. So the first thing that I think it's definitely good to know about is like, how are you actually going to get Power BI connected to Databricks SQL? Kyle mentioned Partner Connect, I think previously in the presentation. And so if I go to the Databricks SQL UI experience and I click on the Partner Connect button, Power BI is actually part of Partner Connect. And so it's extremely easy to kind of get up and running with Databricks SQL by using the Partner Connect kind of Power BI icon. And so from here, I'm basically going to click on Power BI. I'm going to click on my SQL endpoint that I actually want to connect to, and I'm going to click on download the connection file. And then from there, on a machine in which I have Power BI Desktop already installed, I'm basically going to open that connection file, and it's going to launch me, directly into a Databricks SQL experience and provide me with basically the databases tables that I have access to without having to go through any really steps per se within Power BI. So as it kind of spun there and kind of made a connection, it's automatically connecting me to Databricks SQL using my Azure Active Directory authentication and showing me which kind of catalogs and databases I have access to. So I'm going to go to the Hive Metastore, which is kind of like the default managed metastore through Databricks. And then I'm going to just type in taxi. And you can see there's a lot of taxi demo databases in this workspace because it's kind of like a demo Databricks workspace. And you can see here's the taxi database that we've been kind of working with and interacting with. So I'm going to pause here. I also want to show you the more manual way to kind of get connected, just in case you want to have more control or just want to understand what that workflow looks like as well. So I'm going to hit cancel here. Next, I'm going to open up a new session of Power BI. So in order to, I guess, manually create a connection to Databricks SQL, I'm going to go to Get Data, and I'm going to click on More. And then once this gets loaded up, we're going to click on Azure. And then we're going to click on Azure Databricks. So from here, like you can see that it's kind of prompting me for some additional information. So it's asking me for the server host name and for the HTTP path, and potentially even like the option of which database I want to connect to. So where do I find that information? So I'm going to go back to the Databricks SQL UI, and then on the left-hand side of the screen, I'm going to click on SQL endpoints. SQL endpoints are effectively computes that you can kind of bring up and running to basically interact with Databricks SQL. From a UI permissioning standpoint, as an administrator, you have the ability to kind of create multiple computes. Within these compute options, you can give permissions to different types of users or different groups of users. So there's a lot of fine-grained permissioning that can kind of go into this assignment. But I'm going to shoot this kind of shared endpoint photon. And then from that, I'm going to go to connection details. And then on the connection details tab, I can see the connection information for what I need for Power BI. So I copied that, go back into Power BI. Kyle was, I think, reviewing this a little bit earlier, but there's this concept of the fast evaluation mode. It defaults to enabled, so I guess in theory, if you don't set it, it's gonna default to enabled anyways. This basically tells the connector to use the Power Query native execution engine. It's going to give you better performance and a better experience. There's backwards compatibility to allow you to disable it just in case you've got some options deployed that are not using fast evaluation and you're not ready to kind of deploy that into production. But yeah, the best practice is kind of use enabled or just kind of leave it blank. From here, I have the option to kind of pick import a direct query. I'm going to select direct query. When I select that direct query option, that basically means that every single interactivity that I do within the Power BI environment is going to send a query back down to Databricks SQL endpoints in order to kind of execute and run those queries and then send the results back. Import, of course, is going to be the mode where I'm going to physically kind of transfer the data from Databricks SQL into Power BI, and all the data is going to live in kind of the in-memory storage space within Power BI. So I'm going to click OK. And then once I click OK, it's actually going to give me multiple options. Well, it actually didn't. Because I've already signed in, it's actually kind of skipping a step. But there is actually two different authentication options for authenticating into Databricks SQL. So there's Azure Active Directory authentication. That's probably going to be the better practice. That's going to allow everybody to connect to Databricks SQL kind of per user. And then there's actually this option of connecting via PAT tokens. I'll show you where you would actually affect and obtain a PAT token. The PAT token option may be a good option if you have some long-running import jobs, or if you're trying to effectively kind of deploy potentially like a really large enterprise semantic model that's being developed in Power BI, premium large data sets as an example, connecting to Databricks SQL, and you're trying to serve that up to a lot of users, and it's a really big data set. So if you have like really long running kind of imports, maybe the PAT token option might be a good example. And you would actually go and fetch those PAT tokens through the Databricks SQL UI. Again, in some of these environments, this is going to be locked down capability, so not everybody's going to be able to do this. But you can go to settings and go to user settings, and then personal access tokens, and you actually can kind of generate a personal access token and use that within Power BI. Again, this might be locked down. These do have kind of a lifetime that you can set. Administrators can kind of set a max lifetime on these values and whatnot. And these are kind of like a per user, basically kind of token that gets created. So when I create this token, it actually emulates my security privileges. And so if I only have access to one database, when I provision this token and use it in Power BI, I'm only going to see the database that I have access to. Okay, well, from here, again, we're going to kind of recreate this report. We're going to connect to our Hive Metastore. I'm kind of going to review the databases we have access to. So I'm going to click on Taxi again, scroll around to my Taxi database. And I'm going to just start checking boxes to import some tables into Power BI. So I want daily trips. I want my date dimension table, my raw trips, my payment type, and my rate code, my taxi zones, and I think there's a vendor table down at the bottom I want as well. So I have the option to basically transform the data or load the data. Transforming the data is going to click me into my Power BI, my Power Query experience right away without actually saving any of the tables. And then loading in is just effectively going to kind of load those models. Since we're using direct query and I'm actually not doing any import at this particular point in time, I'm just going to click load and just kind of see those tables pop up. Okay, so now I've got my tables loaded. The next thing I'm going to do is actually kind of go into the modeling view within Power BI and just do some quick organization, kind of get my tables laid out the way I want them. And then I'm going to start, basically beautifying, making some relationships and kind of building out my model. So one thing that I know from this, because I know this data set well, is that there's actually this concept of basically a pickup location and a drop-off location, and those both actually refer to taxi zones. And so I know that I need basically multiple taxi zone tables, kind of like going a little bit old school. This is kind of like the concept of like role-playing dimensions. So I'm actually going to duplicate this table and create another version of it. So I'm going to open up the Power Query editor. I'm going to go to taxi zones and I'm going to duplicate that table. And then I'm going to just do a quick rename. I'm going to call this one drop-off zones. And I'm going to call this one pickup zones. And then I'm just going to, for the sake of beautification, kind of change some of the names of the rest of these tables. Okay, so I'm going to, now that I've kind of done that and I have all the tables that I need, I'm going to go ahead and close and apply these. And effectively this will kind of get kind of created my Power BI data model. These are still all basically be in the storage mode, still direct query. So all of these tables are still kind of interacting with Databricks SQL, kind of like every movement that I do. At this particular point in time, like when you're in Power Query, there's depending on what data source you're connecting to and kind of like what mode you're operating in, there's different things you might do within Power Query. So as an example, like I can maybe basically apply steps and kind of transform and kind of shape the data directly in Power Query, and those changes in shape transformation changes would basically be take effect and kind of be in place within the Power BI data model. Also within Power BI, right, I have the concept of kind of creating calculated columns within DAX, and so within the actual Power BI data model, I can create calculated columns. Generally speaking, I think when you're kind of interacting with Databricks SQL, the general guidance is to try and push as much down as possible effectively to the Databricks SQL layer. There are going to be instances where you're going to want to effectively kind of make changes or apply patterns kind of directly inside of Power Query. So as an example, this is actually a poor example, but I want to kind of show this. I can go to the Add Column button. I can create a custom column. And from a custom column standpoint, this is just a really bad example, but I'm just going to call this year, day of week, and I'm going to just concatenate some strings together just to kind of show what this looks like. So calendar month, just creating a space between the two, and then the day of week. And since both of these are strings and I'm concatenating together, this actually, well, that was a bad example. What's the one I created in my previous example? Sorry. So calendar month and calendar day.
You got to stick to the script, Leo.
Yeah, I got to stick to the script.
Can't wing it.
So this is just an example, and again, I don't think anybody would ever make this type of column, but there are operations that you can do within Power Query that can be pushed down to Databricks SQL. So this might be a kind of a good thing to show, but within the Databricks SQL ecosystem, I can actually go back to Databricks SQL, and there's this concept of the query history. And so within the Databricks SQL UI, I've got a query history, and right now I've got this selected myself, and I'm looking at queries for the last hour, and then click refresh. And effectively, I can see the queries that Power BI is actually executing into the server, and I can see that it's actually concatenating those two columns together. So there's going to be certain functions and items that are going to be able to push down when you're kind of developing in Power Query, and then there's going to be certain functions that you develop that won't be able to push down. And so it's just important to kind of keep that in mind as you're kind of performing these observations in Power Query. You need to be cognizant of what's going to be, depending on the storage mode that you're going to kind of go after from a strategy standpoint. Some of these items may not be able to push down, and you're going to want to push those to the data source as much as possible. So I've got another example that I actually created to just kind of show how it won't get pushed down, and you should get an error message if that's the case. I'm going to cheat a little bit because I created the formula ahead of time. Oops, not that one. So this is an example of actually something you might want to do from a date dimension and calculated column standpoint. Maybe in my date table, I don't have this concept of a year month. So a lot of times within date dimensions in Power BI or just in BI tools in general, you may want to combine the year and the month together to kind of create almost like an integer-based year month that's really good for sorting and maybe even potentially good for creating DAX formulas. And so from this standpoint, you can see I'm taking the Power Query end function number.toText. I'm turning the calendar year basically into a string, and then I'm going to concatenate that with basically a 0 concatenated with number.toText in the month of year. And then basically I'm just going to take the 2 digits from the right using a SQL write type of function. And so from that standpoint, I would have year, and then month as my code. And as you can see here, once I click OK, this cannot be pushed down. So Power Query is doing it, but it's basically saying this results in a query that's not supported by indirect query mode. So switch the table to import mode. So it's just, you want to be cognizant of what's going to get pushed down and what's not going to get pushed down. And from a strategy standpoint, just make sure that as you kind of go through and you're kind of doing some of these functions, just kind of be cognizant of what's going to be able to push down and not be pushed down. And you should get some warning messages that kind of indicate that along the way.
So Leo, I'm going to try to summarize that. The best strategy is to do it in Databricks SQL if you can. Do it in Power BI if it makes more sense for other users, especially maybe to share from a collaboration standpoint. But but if you're going to import if you're going to do something that results in an import, it's almost always better to just go back and find a way to do it in your source system if you want to retain that.
Yeah, I would agree. Okay, thanks, Kyle. I appreciate that. So I guess for the purposes of this demo, I think we've basically that's what I'm going to show from a Power Query kind of interactivity standpoint. The next things I want to do is basically start kind of shaping and creating my data model within Power BI. If you and again, I think we have a potentially a mixed audience today, but Power BI loves the concept of star schemas, and so when you're kind of building out your model, it's kind of important to kind of keep that in mind, that it really likes that kind of shape and structure in regards to how you kind of build your data models. You can create kind of flat reporting tables. I know that's really popular in a lot of other BI tools, but Power BI kind of really loves that concept. So here I've got my drop-off location ID. I know that joins to my location ID table, so I'm going to make a connection, kind of join those tables on that column. And you can see that Power BI is able to run a direct SQL a direct query against Databricks SQL. I'm going to do some profiling and make a recommendation for the join relationships. One thing that's kind of a pet peeve of mine when I make joins is I like to hide the join columns. I'm going to go ahead and hide those join columns as I go as well. I actually did this in a different order when I previously built this Power BI workspace. I like how Power BI now, when you make that join condition on a column, you can see how even though location ID is an integer, and it previously had a default kind of summarized by is a sum, even though it's an integer, it actually changed it to none by creating that relationship. So that's actually really cool. That's probably not a new capability, but I'm seeing that happen. So I've got my drop-off location ID. I've also got my pickup location ID. Ooh, I joined to the wrong table, didn't I? I did. So this is my drop-off, and I joined to the pickup table. So I'm going to change that to the pickup location ID column and save that. And then I've got my drop-off ID column. I'm going to join that to the drop-off table on location ID. And then my pickup date is going to be kind of like the main date that I'm using for my analysis on these transactions. I'm going to join my pickup date to my calendar date table. And then from that standpoint as well, my trip summary table, I'm going to join to my calendar, my date dimension on the calendar date as well, using the pickup date. So I've got my rate code ID. I'm going to join that to my rate table on rate code ID. Hide that column. Now I've got my vendor ID column, and I've joined to my vendor table on vendor ID. And then finally, I've got my payment type table, and I'm going to join on the payment type ID. One thing that I think is a great capability on Power BI that's really interesting. You do have to be careful of this capability, especially kind of depending on which kind of storage mode you're using. But on the trip summary table, I basically have the drop-off bureau in my trip summary table. So in theory, the bureau is at a certain level of granularity. In my drop-off table, bureau is at a higher level of granularity from a hierarchy standpoint versus location ID. But Power BI actually lets me join the bureau, the borough table, or the borough column to the drop-off zones table on the borough column, even though that's not the lowest level of granularity. And so that it's kind of a neat capability in Power BI that lets you just create some additional functionality they wouldn't be able to otherwise from a relationship standpoint. So I still want this to be kind of like a single direction. I want the drop-off zones to filter the trip summary. So I'm going to click OK here. So I've created all my relationships in this data set. From here, if I wanted to, if I wanted everything to be direct query, I can go ahead and go off to the races, and I can start developing my report. Again, especially this trips table, this is a 400 million record table, right? And I only loaded 2016 to 2019. There's more data that I could potentially load into this table to kind of give people access to from a Power BI standpoint. If I were to import all of that data, potentially that could take up a lot of space in my Power BI desktop file. And when I deploy it to the service, depending on the size of the Power BI desktop file, I might start breaking some of the thresholds for Power BI Pro versus Power BI Premium requirement. I believe that threshold is still 10 gigabytes right now, so it's likely that I'd probably stay underneath it. But again, I want to potentially kind of minimize the number of refreshes I have to manage from a refresh standpoint. or maybe like data gets loaded intraday and I want to be able to kind of have quick access to that. So from that standpoint, in this particular Power BI report, we're actually going to kind of mix some of our storage modes. And so because trip summary, is something that we really want to be super quick and super snappy, we're going to go ahead and change the storage mode for trip summary to actually be import. And so this gets into the concept of what Kyle was talking about earlier, which is basically the concept of composite models. So within Power BI, you can create this concept of composite models where I can kind of mix and match the storage modes that I use for different tables to meet the expectations of the user. And the great thing is the Databricks SQL connector supports that. So you're going to be able to create composite models within Power BI going against Databricks SQL. And then from that standpoint, more from a just kind of a best practice point of view, any tables that are interacting with any kind of dimension tables that are actually interacting with a import table and a direct query table need to be set into the dual storage mode. So when I go to the date table, you can see that Power BI kind of gave me that warning when it popped up on the screen. And this, it automatically changed my date table to dual storage mode. So that's the best practice. You can see that Power BI actually did it for me anyways. Right now, I'm actually going to go to all of my dimension tables and I'm going to change them to dual so that effectively they can work with direct query interactions and also import interactions. And really, I think the benefit to that is that when you kind of set the some of the dimension tables to dual, when you use them actually as like slicers or maybe filter values within the Power BI interface, it's going to be intelligent enough to kind of serve that data out from memory and give you a really kind of fast and snappy interactive experience. But then when effectively you're interacting with direct query tables, it's going to be intelligent enough to serve those results up from the direct query mode and actually send those results back to the compute engine. So Kyle, I know this can be a confusing topic. Is there any questions on this particular design element?
No, I think we're good. I mean, there's again some very specific questions to address, but they've been addressed. No, I think we're good.
Okay, cool. Okay. So now that I've actually basically set my my dimension tables to dual, there's some additional functionality that I can kind of leverage within Power BI. So the first thing I actually want to do is basically just kind of do some beautification, some formatting, and we'll keep it limited. But I'm going to change my calendar date or my date column to basically kind of a short date time frame formatting option. I also have the ability to basically set my date table as a date table. And when I do this, it actually allows me to kind of tap into some of the like time intelligence functionality that's actually kind of built directly into Power BI and some of the kind of the DAX functionality that kind of like automatically happens from a time intelligence standpoint. So I'm going to go ahead and set my date table. Another pretty common thing that people do actually kind of set the default sorts. So like I can go into column tools like calendar month. This is obviously a string column. Potentially we would want to have that sort by month of year to get the user a good experience from a interactivity standpoint. And the same thing with like the calendar day of week. And then another pretty common like practice within this, right, may be to kind of create some DAX calculations. And so before we kind of start charting and kind of creating some DAX, just want to or creating some reports, I just want to have a kind of a quick conversation about DAX calculations. Generally speaking, like we talked about with like calculated columns in Power Query, DAX calculated columns can also be potentially problematic. So when you create DAX calculated columns, you just need to be kind of cognizant and aware that some of those calculated columns may be able to be pushed down into Databricks SQL, and they may not be able to. So typically, when you create a column that can't be pushed down, you potentially might get an error. When you actually kind of use it on the interface, so there's going to be kind of a dead giveaway. But you just want to be kind of aware of that not all kind of DAX calculated column concepts can kind of be pushed down to Databricks SQL when you're in direct query mode. DAX calculated measures, kind of, the same thing applies in regards to potentially not everything could be pushed down when you're in direct query mode. With any type of data source, there's going to be kind of a limitation, potentially in some of the DAX calculations that you can create. So for now, I'm just going to create some kind of pretty simple DAX calculations. We're going to create a trip count and then kind of like a trip count prior month to just kind of show how we can use some of those built-in time intelligence capabilities. So in this case, I'm just going to create a really simple calculated column called trip count. And then I actually want to create a trip count prior year as well. Just for simplicity, I went ahead and created that one ahead of time. So my trip counts prior month is going to be equal to calculate. I'm going to sum my trip summary kind of trip count column. And then because I created that date table, I can use some of the time intelligence kind of functionality built into Power BI. So I'm going to do previous month and then basically the date, calendar date column. And that's going to give me my trip summary. Okay, cool. So from here, we've created, again, I'm not going to attempt to kind of create the entire Power BI report today, but we've created, we've added some of our tables, we've created some of our relationships, we've added some, pretty quick DAX calculations. And so let's start kind of creating some data visualizations on the screen and start kind of creating some of these reports, recreating some of these reports. So I've got my date table, and I'm actually going to bring my calendar year column into the pane. I'm going to make that as a slicer, and I can make that as kind of like there's multiple options. I can do that as a between, a list, or a drop down. So I'm going to make this actually a list, take up less, a drop down, take up less screen real estate. I'm going to go ahead and select 2019. And then I'm going to take my calendar month. I'm going to make that a slicer as well. From here, we can make just a really quick kind of bar chart with our trip counts from our summary table. And again, the interactivity for this should be very snappy and quick. And I'm going to go to my drop-offs table and actually select the borough, put that on the axis. And then I'm going to go back to my table and go to trip summary and actually get my trip count prior month as well and add that. One thing that kind of clutters the experience, effectively, this data is not 100% clean. Like there's actually an unknown value in the borough in the actual data set. So I'm actually going to remove those from the chart just for creating a better experience for the user. So I'm going to go to the filter on this visual. I'll select all. I'm going to get rid of the blank, and also I'm going to get rid of the unknown down at the bottom. From here, one thing that we didn't do yet, actually, let's go back and do that really quickly. One thing that's really great about Power BI is some of the built-in kind of mapping functionality within the product. So when I go to the drop-off zones, I can actually go to Burrow, and I can set some of the kind of settings for the data category of that column. So like Power BI is going to kind of automatically kind of treat that column and do certain functions and capabilities kind of right off the gate. So Burrow is a basically a place. I've also got my longitude and latitude columns. So I'm going to specify the longitude column as the longitude, and the latitude column as the latitude. And then I'm going to do the same thing for the pickup table as well. So from here, basically we're able to now we can kind of start kind of charting and kind of creating our map. So I'm going to go to my drop-offs table. I'm going to select the Burrow, kind of drag that onto the screen. Power BI is going to automatically kind of create that map visualization for me. I'm going to kind of size that map using my trip summary and my trips counts measure, and add that to the screen. And then notice too, like this unknown kind of Burrow that basically pops up in Indianapolis for some reason. So we're going to go ahead and filter that out, just kind of create a better experience for the user. And there we go. So we've got a better visual for the user as well. One thing that I was doing on the previous report, and we can kind of see what that might look like from a differences standpoint, is that when I go to like drop-off locations, I can actually take the the latitude and longitude and kind of add those to the visual as well. Also, so latitude goes to the latitude box. And so you can see there's a lot of data points. And then now when I actually kind of go to my trips table and select trips count, actually put it in the wrong location. I'm pretty sure you can move it. Well, this is for my trips table, so I put it in the wrong table. I honestly can't remember for the life of me how you actually, if you create a measure in the wrong table, how you move it to the right table. Obviously, I could delete it and recreate it, but you can see when I actually drop the trip count into this visualization, I'm starting now to actually query that 400 million record fact table. So if I click on this, this Burrow as an example, it's going to filter the results. And again, actually, that was pretty quick. So for this trip counts measure, oh, that's why it was quick. So this trip count measure, kind of again put this back on size. You could see, that it filtered, but this is actually kind of querying the fact table right now, kind of in real time. So if I click on a Burrow, then it's going to kind of filter the data. If I click on Queens, since we haven't actually looked at that yet, it should be a pretty fast interactive experience. So there we go. So I wanted to show the wheel actually spinning. So this is actually issuing a query in real time to Databricks SQL, and so you can see that the storage mode kind of changes the experience for the user. So potentially you might want to create visuals on like a summary dashboard using basically the summary table, and then maybe have like drill to details into like a drill through table, or maybe into a tooltip, so users can kind of like see the intimate details of those like plot locations, and not necessarily have to kind of wait for those results to come back through to the dashboard. Actually, but from this standpoint, you can see it's pretty quick, even though I'm kind of running those queries in real time. On that 400 million record set table, the interactivity is pretty quick right now. So effectively at this particular point in time, we've connected to Databricks SQL. We've started kind of creating some reports. Obviously, we haven't fully kind of recreated the dashboard yet, but in the interest of time, because we are starting to run out of time, I did want to kind of leave you with this concept of, okay, we're actually creating a dashboard. We're going with the kind of direct query option. What if we actually run into some performance problems? Like, what do we do? And from that standpoint, there's a kind of a great blog post out there, actually on Chris Webb's blogs, that actually coaches you through how to kind of go through looking at kind of direct query analysis using the Power BI Performance Analyzer, and also the query diagnostics through Power Query. And so in addition to that, we can also take a look at the query results through the query history UI, actually inside of Databricks SQL as well. So you can see some of these more detailed queries that I've actually been running are getting pushed down to Databricks SQL. We're looking at the trips table, the raw trips table, kind of interjoined with the dim date, and also the taxi zones table. And you can see, like, because we're hitting cache, like the query history UI will actually tell you if you're hitting cache as well. In this case, it doesn't look like we were. But you can see that query took 816 milliseconds. But again, if you're having a kind of a bad performance experience, or you're trying to kind of troubleshoot that interactivity and make it as fast as possible, you can also go to the performance analyzer within Power BI, and you can actually kind of basically start recording the performance analyzer, and you can kind of click one of those dots, like issue kind of like some interactivity within Power BI. It's going to show you the queries that are actually executing within Power BI, more from a visualization standpoint. Now, with certain type of direct query sources, a lot of times that you may not be able to get the actual query that's being issued down to Databricks SQL. In this case, it actually looks like we were able to. Oh, so here's the DAX query that was actually executed by the visualization. So this is giving you the actual DAX query through the UI. And so we can go to those different UI experiences and kind of look at the times for each of those visualization. We can look at the DAX query. If we want to look at the query that actually got pushed down to Databricks SQL through the Power BI experience, we can go to open up the Power Query UI and actually turn on the diagnostic settings through the Power Query UI. So I'm going to click on Tools, and then I'm actually going to start the diagnostics, and then go back to my data visualization. I'm going to change this from 2019 to 2018, and then that's actually going to basically issue some queries. I'm going to click on the Bronx, and that basically that query is kind of running in Databricks SQL. I'm going to go back to my query diagnostic logs. I'm going to stock my diagnostics. And then what you're going to see here, actually in the diagnostics is these, what's actually being kind of pushed through Power Query. So I can go through and kind of look at these logs. I can see this is row 20 is kind of the query that got executed by Databricks, or to Databricks. And then I can actually look at the individual query that was run. And then here's the detailed query that was run. It kind of gives us it tells us this is the 94% of the duration was kind of taken up on this step. It tells us how long this query actually ran. It looks like this step took about 2 seconds. And then it gives us the actual individual query that we can then use to kind of go and plug into the Databricks SQL IDE and kind of play around with, and potentially like looking at some performance kind of improvement options, more from like a DBA standpoint or something like that. Well, cool. I think with the time allotted, for the most part, this is like all the content that I wanted to cover today from a demo perspective. Kyle, do we have any questions in the chat, or are there any other kind of concepts that you wanted to kind of bring up or talk through today?
No, I think we're good. I mean, there hasn't been any. There's been good questions in the chat. They've been, more specific to the platform and Databricks, so some good kind of questions. But I think, as a whole, I just want to thank everyone for their time. Really hope that this gets you kind of started on your journey with Power BI. We'll be sharing out some of all of this content, the finished Power BI file and report, and some steps to kind of at least some of this. You have the video to go back and watch. So really hope that people take advantage of this, get out there, start trying some things. The New York City taxi data set's available, as Matt helpfully posted on the Microsoft site. It's also available in Databricks as a data set. So it's really easy for you, if you have Databricks, to go do the exact same steps that Leo's doing right here. So I just wanted to kind of encourage everybody to go kick the tires yourself, especially on some of that direct query import mode. There were some questions about that. We'd love for you to test performance, to make sure that your own permissions and environments are set up the way that you want. And start solving real problems with this. So thank you.
Absolutely.
Awesome. Thanks so much, everyone. And we'll get this posted, the recording posted on YouTube, so you can watch it again and get back in the details. If you've got any questions, feel free to send an email to msusdev@microsoft.com.
Awesome.